Okay, so our next section in Chapter 1 is Section 1.7, Dimensional Analysis. So dimensional analysis is useful because it's often necessary to convert from one unit system to another in chemistry. So this can also be called unit conversion. Dimensional analysis is the more technical name. So it's conversion from one unit system to another. Table 1.4 in your book gives you a list of English metric equivalents for length, mass, and volume. So for length, 1 meter equals 1.094 yards. 2.54 centimeters equals 1 inch. For volume, 1 liter equals 1.06 quarts. 1 cubic foot equals 28.32 liters. Okay, and then a couple of different conversions for mass. 1 kilogram equals 2.205 pounds, and 453.6 grams equals 1 pound. Okay, so these are just some examples of going from US to metric. Okay, so let's move on to a couple of examples because right now this probably doesn't make a whole lot of sense. Okay, example. The pen is 2.85 centimeters long. How long is the pen in inches? Okay, so we can use this conversion factor that we just wrote over here. So 2.54 centimeters is equal to 1 inch. So you always start with what you're given. So we're given that the pen is 2.85 centimeters. And then our unit conversions are always written as a fraction. So you can write them two different ways, either 2.54 centimeters over 1 inch or 1 inch over 2.54 centimeters. And which one you use depends on your unit in what you're given. So right now we have our unit in the numerator for our given number is in centimeters. So we need centimeters in our denominator. Okay, and this is because when we go through, we need our units to cancel. We want to be left with just inches. So if we go through this calculation, we can see that we have centimeters in the numerator and centimeters in the denominator. So those two units cancel, and then we're left with inches. So if we do the math here, 2.85 times 1 divided by 2.54. So if the number's in the numerator, you multiply. If it's in the denominator, you divide. So if we do this math, our answer comes out to 1.122047 inches. And now we need to look at sig figs just like we have been. Remember that a definition is an exact number and it doesn't contribute to sig figs. So this is a definition, so it doesn't contribute to sig figs. So we just look at our given number, so 2.85. This has 3 sig figs. Okay, so our answer needs 3 sig figs. So 1, 2, 3, mark where your significant figures will end. So the 2 will be your last significant figure, and now you can round. So we look at the number to the right of the 2 and see if it's equal to or greater than 5, then we would round up. But since it's not, we keep it the same. So our final answer would be 1.12 inches. So keep in mind sig figs every time you do a calculation. Okay, another example. The student has entered a 10K run. So 10K is kilometers. So how long is the run in miles? Okay. So for this one, we're going to have to use multiple conversion factors. So we're going to look at what we're given. Again, that's what you always start with. So we're given that the run is 10 kilometers long. So we're going to go from kilometers to miles. Okay, now we do have a conversion factor here that they gave. 1 meter is equal to 1.094 yards. So first, we need to convert to meters because that's what we were given in that table 1.4. So 10 kilometers times let me keep with the same form. Okay, 10 kilometers. So for every 1 kilometer, there is 1,000 meters. Okay, so kilometers in the numerator, kilometers in the denominator, check. So those will cancel. We have that conversion factor on this other page, meters to yards, so we're going to use that next. Okay, so 1 meter on the bottom, meters in the numerator, meters in the denominator, check, that's what we need. 1.094 yards. Okay, and now we need to go from yards to miles. So this conversion factor is in your book. 1 mile equals 1,760 yards. Okay, so we can plug that in. 1,760 yards for every 1 mile. So now we're going to go through and make sure that our units cancel. Kilometers in the numerator, kilometers in the denominator, good. Meters in the numerator, meters in the denominator, those cancel. Then yards in the numerator and yards in the denominator, those cancel. So now we're left with miles, which is what our goal is here, is to get the run in miles. Okay, so now we would go through and do the math. So 10 divided by 1 times 1,000 divided by 1 times 1.094 yards divided by 1760, and then times 1 would be the last step. So again, remember, if it's in the numerator, you multiply. If it's in the denominator, you divide. So if we go through and do that math, we get 6.2159091. And so that's all the digits from my calculator. Okay, so now we need to look at sig figs again. So this number in the problem, I wrote it wrong up here. It was actually written as 10.0 kilometers. So this number should be 10.0. So we started with 3 sig figs. And remember, all of these are definitions, so they don't count. They have infinite sig figs. So our original number has 3 sig figs, so our answer should have 3. So 1, 2, 3, mark where your last sig fig is, and then determine if you're going to round up and down. So the number directly to the right of the 1 is a 5, so we're going to round up. So that's 6.22 miles. And make sure when you do these types of problems that you don't forget your units. Okay, so that's pretty much it for unit conversion. There's a lot of things that you can do with this. You can convert between metric units and between the metric and US system. So when you guys would use it for metric conversions, it would be something like what we did here, 1,000 meters equals 1 kilometer. So it's really those prefixes that we would use, or 1,000 milliliters equals 1 liter. So if we need to convert from milliliters to liters, or from grams to kilograms, stuff like that. So you can convert between metric units or the US system and metric units, which is what these two examples were. So if you guys have any questions about this section on unit conversion or dimensional analysis, let me know. And do some of the practice problems that I posted for this, because it's a lot easier once you get used to doing these types of problems just to fly through them. So practice, and once you get the hang of it, it should be pretty simple.